Hello, my dear children. Welcome to the mathematics class. Today, we are going to discuss three-dimensional geometry. In this chapter, we are going to discuss the problems in the exercise 11.2, page number 477 in the textbook. In the previous class, we have discussed the concepts of this exercise. I hope you have learnt well the concept of this exercise. Haven't you, my dear children? Right. Now come to the questions in the exercise 11.2. See the question number 1. First question. Show that the three lines with direction cosines 12 by 13, comma, minus 3 by 13, comma, minus 4 by 13, 4 by 13, comma, 12 by 13, comma, 3 by 13, 3 by 13 minus 4 by 13, comma, 12 by 13 are mutually perpendicular. Understood this question, my dear children? Here, direction cosines of three lines are given like this. Now we have to prove that these three lines are mutually perpendicular. Means we have to prove that. Let us consider this is the direction cosines of line L1. These three numbers are the direction cosines of line L2, and these three numbers are the direction cosines of line L3. Okay, my children. So we have to prove that L1 is perpendicular to L2, L2 is perpendicular to L3, and L3 is perpendicular to L1. Understood this question, my children? Right. Come to the solution part. Let the direction cosines, short form DCs. Remember this point, my children. In vector algebra and three-dimensional geometry, we write in the short form DCs. DCs denotes direction cosines of a line. Okay, my children, remember this point. So, direction cosines of three lines, capital letter L1, comma, capital letter L2 and capital letter L3 are direction cosines of L1. Ordered triplet L1, comma, M1, comma, N1 is equal to 12 by 13 minus 3 by 13 minus 4 by 13. Okay, my children, we wrote the ordered triplet of direction cosines of line L1. Similarly, we are writing here direction cosines of line L2. Ordered triplet L2, comma, M2, comma, N2. That is equal to ordered triplet 4 by 13, comma, 12 by 13, comma, 3 by 13. Understood this statement, children? Similarly, here we are writing the direction cosines of the third line L3 is equal to ordered triplet L3, comma, M3, comma, N3 is equal to 3 by 13, comma, minus 4 by 13, comma, 12 by 13. Understood this statement, children? Right. Now we have to prove that L1 is perpendicular to L2. Okay, my children. Similarly, we follow the same procedure to prove that L2 is perpendicular to L3 and L3 is perpendicular to L1. Okay, my children. So here I will explain how to prove the lines L1 is perpendicular to L2. Okay, my children. Remember these steps and follow the same procedure to show that the line L2 is perpendicular to L3 and L3 is perpendicular to L1. Okay, my children. Right. Do you remember that point, my children? When the two lines are perpendicular to each other in the three-dimensional geometry, the direction cosines of two lines are given. Yes, L1, L2 plus M1, M2 plus N1, N2 is equal to 0. If this condition is satisfied, then the two lines are said to be perpendicular to each other. Do you remember this point, my children? If the direction cosines are given, then what is the condition? A1, A2 plus B1, B2 plus C1, C2 is equal to 0. When the direction cosines of two lines are given. Here, direction cosines of the two lines are given. So, let us find the value of L1, L2. Now, let us find. Now, L1, L2 plus M1, M2 plus N1, N2. Let us find the value of this expression. What is L1 here? 12 by 13. 12 by 13 into what is L2 here? 4 by 13. Okay, my children, this is the first term. Into M1, M2. What is M1 here? Minus 3 by 13. Into what is M2 here? 12 by 13. This is the second term. Okay, my children. Now come to the third term. n1, n2. What is n1 here? Minus 4 by 13. Minus 4 by 13 into what is n2 here? 3 by 13. This is the third term. Okay, my children, we are finding the value of this expression. If you get the value of this expression is 0, then we can say that these two lines are perpendicular to each other. Okay, my children, right. So we substituted the values of L1, M1, N1 and L2, M2, N2. After substituting these values, let us simplify these three terms. That is equal to, what do you get here? 12 fours are 48 by 169. Yes or no, my children? Minus 36 by 169 minus 4 3s are 12 by 169. Understood this step, my children? Right. Let us take LCM. And 169 is LCM. So what you get in the numerator? 48 minus 36 minus 12. Then what will you get? 48 minus 48 by 169. That is equal to 0 by 169. 0 by any number. What do you get here? 0. So we get here L1, L2 plus M1, M2 plus N1, N2 is equal to 0. Okay, my children, this condition is satisfied. Therefore, we can say that L1, the lines L1 is perpendicular to L2. Okay, my children, hence proved. Similarly, we can prove that. Similarly, we can prove that L2 is perpendicular to L3 and L3 is perpendicular to L1. Okay, my children, understood this step? Right. Now come to the second question of the exercise. Question number 2. Show that the lines through the points ordered triplet 1, minus 1, 2, ordered triplet 3, 4, minus 2 is perpendicular to the line through the points ordered triplet 0, 3, 2 and ordered triplet 3, 5, 6. Understood this question, my dear children? Yes. Here 2 points are given. The line is passing through these 2 points and another 2 points are also given. From these 2 points another line is passing. We have to prove that the 2 lines are perpendicular to each other. Okay, my children, right. Come to the solution part. Now let us consider the 4 points are namely A, B, C, D. I denoted A, x ordered triplet x1, y1, z1 is equal to 1, minus 1, 2. Similarly, second point B, ordered triplet x2, y2, z2 is equal to ordered triplet 3, 4, minus 2. Similarly, third point C is equal to x3, y3, z3, that is equal to ordered triplet 0, 3, 2. Okay, my children. And the fourth point D is equal to x4, y4, z4, that is equal to ordered triplet 3, 5, 6. Understood these steps, my children? Right. Now let us find the direction ratios of the line AB. You have already learnt in the previous exercise. If a line is passing through 2 points, namely x1, y1, z1 and ordered triplet x2, y2, z2, then how do you find the direction ratios of the line AB? Yes, let us denote it by A1, B1, C1 is equal to x2 minus x1, y2 minus y1, z2 minus z1. Do you remember this formula, many children? To find the direction ratios of a line which is passing through the 2 points, namely x1, y1, z1, x2, y2, z2. So that is equal to, what is x1 here? 1 minus 1, 2. x2 is x2, y2, z2, 3, 4 minus 2. Let us substitute these values in the formula. 3 minus 1, y2, 4 plus 1. Here I am writing the values directly. Okay, my children. Z2 minus Z1. Minus 2, minus 2. Okay, my children. Understood this step? Right. Now let us find the values. 3 minus 1 2, 4 plus 1 5. Here minus 2 minus 4. These are the values of ordered triplet A1, comma B1, comma C1. These are the direction ratios of the line AB. Understood this step, my children? Right. Similarly, let us find direction ratios. Direction ratios of the line CD. That is equal to, let us denote it by A2, comma B2, comma C2. So we are finding the direction ratios of the line which is passing through the 2 points C and D. So how do you find direction ratios? X4 comma X4 minus X3. Similarly Y4 minus Y3. Z4 minus Z3. Understood this step, my children? Right. In this step, let us substitute the values. X4 3 minus 0. Next 5 minus 3. Next Z4 6 minus 2. Understood this step, my children? Right. Let us simplify the numbers. What we will get here? First number 3, second number is 2, and the third number is 4. These are the values of A2, B2, and C2. We got here direction ratios of the first line, and as well as we got the direction ratios of the second line. Okay, my children, A1, B1, C1, A2, B2, C2 values were found. Then what should we find? Let us find the value of the expression A1, A2. Now, A1, A2 plus B1, B2 plus C1, C2. Let us find the value of this expression. If you get the value of this expression is 0, then we can say that these two lines are perpendicular to each other. Do you remember this condition, my children? Right. Now in this expression, let us substitute the values. 2 into 3. This is the first term, plus B1, B2. 5 into 2 plus C1, C2 minus 4 into 4. Understood this step, my children? Right. Let us simplify. 6 plus 10 minus 16. What you will get here? 16 minus 16. That is equal to 0. We got here A1, A2 plus B1, B2 plus C1, C2 is equal to 0. So we can say that the lines AB is perpendicular to CD. Therefore, line AB is perpendicular to line CD. Hence, proved. Understood, my children? Right. Now come to the next question, that is question number 3. Third question in the exercise. Show that the line passing through the points ordered triplet 4, 7, 8, ordered triplet 2, 3, 4 is parallel to the line through the points ordered triplet -1, -2, 1, ordered triplet 1, 2, 5. Understood this question, my children? Here a line is passing through these 2 points and the second line is passing through these 2 points. We have to show that, we have to prove that the first line is parallel to the second line. Understood this question, my children? Right. Now come to the solution part. As we followed for the previous question, till direction ratios, till you are finding the direction ratios, we follow the same steps here. Okay, my children, A is equal to ordered triplet x1, y1, z1, that is equal to 4, 7, 8. B is equal to x2, y2, z2, that is equal to ordered triplet 2, 3, 4. Third point, C is equal to x3, y3, z3, ordered triplet -1, -2, 1. And fourth point, D is equal to ordered triplet x4, y4, z4, that is equal to ordered triplet 1, 2, 5. Okay, my children, understood these steps? Here I am finding the direction ratios of the line AB. Similarly, here I found the direction ratios of line CD. We follow the same steps as we followed for the question number 2 to find the direction ratios of a line passing through 2 points. Okay, my children, understood these two? direction ratios of this first line AB and the direction ratios of second line CD. Here again I am not explaining in detail. Okay, my children. Right. Now we have to prove that the two lines line AB is parallel to line CD. Here we have to prove that these two lines are parallel. Do you remember that point, my children? When the two lines are parallel to each other, if the direction ratios of the two lines are given, yes, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. If this condition is satisfied by the two lines, then the two lines are said to be parallel to each other. Therefore, let us find A1 by A2. What is the value of A1 by A2? Minus 2 by 2. That is equal to minus 1. Okay, my children. Similarly, B1 by B2. B1 minus 4 by 4. What do we get here? Minus 1. Similarly, C1 by C2. Minus 4 by 4. That is equal to minus 1. In all these three cases, we got the same value. Minus 1, minus 1, minus 1. So, all these three ratios are equal. Here, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So this condition is satisfied by the given two lines. Therefore, we can say that line AB is parallel to line CD. Understood this step, my children? Hence proved. Understood, my children? Right. Now come to the question number 4. Fourth question in the exercise. Find the equation of the line which passes through the point ordered triplet 1, 2, 3 and is parallel to the vector 3i cap plus 2j cap minus 2k cap. Understood this question, my children? If a line is passing through this point and parallel to this vector, then we have to find the equation of the line. At the time of concepts, we have discussed there are two forms of a line: Cartesian form and vector form of a line. So here I am writing the two forms of the line. Okay, my children. Let us consider the given point is A bar with the position vector A bar, that is equal to ordered triplet 1, 2, 3. This can be written in the component form. You know, a vector can be written in the component form as well as in the form of ordered triplet. Okay, my children. So this can be written as I cap plus 2j cap plus 3k cap. I wrote this vector, position vector of this point in the component form. Do you remember this point, my children? Right. Now the given vector, let us consider this is B bar. 3i cap plus 2j cap minus 2k cap. Understood this step, my children? Right. Now let us recall the formula. What is the formula? The equation of the vector equation of a line passing through a point with the position vector A bar and parallel to the vector B bar is, we know that the vector equation of a line which is passing through point A, which is passing through the point A, whose position vector is A bar and parallel to the vector B bar, is R bar is equal to A bar plus lambda B bar comma lambda belongs to R. This is the formula. Remember this formula. Previously I told you at the time of concepts. So just by using this equation, we have to write the equation of the given line in the vector form. Therefore, vector equation of the given line is R bar is equal to, what is A bar here? I cap plus 2j cap plus 3k cap plus lambda into, what is B bar here? 3i cap plus 2j cap minus 2k cap, comma lambda belongs to R. That's all. This is called the vector equation of the line. Understood this step, my children? Right. Now come to the next part. We know that the Cartesian equation of a line passing through the point ordered triplet x1, y1, z1 This is nothing but given point 1 comma 2 comma 3 and parallel to a vector b bar whose direction ratios are a b c. These are called direction ratios 3 comma 2 comma minus 2. Okay, my children. The coefficients of I cap, j cap and k cap respectively are said to be direction ratios of the vector. Okay, my children, do you remember that point? Right. Is x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. You have to remember this formula for this question to write the equation of a line in the Cartesian form. Simply, you have to substitute the values of x1, y1, z1 and a, b, c in this equation. Then we get the Cartesian equation of the required line. Okay, my children, understood this step? Right. This implies x minus, what is x1? 1 by a, what is a here? 3 is equal to y minus y1. Y minus y1 is 2 by, what is b here? 2 is equal to z minus z1. Z minus 3 by c. What is c here? Minus 2. That's all. This is the Cartesian form of the given line. Okay, my children, understood? Right. Now come to the question number 6. Here I am not explaining question number 5 because question number 5 is the same as that of question number 4. Please try question number 5 yourself. Okay, my children. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children. Right. Come to the question number 6. Sixth question in the exercise. Find the Cartesian equation of the line which passes through the point minus 2 comma 4 comma minus 5 and parallel to the given line x plus 3 by 3 is equal to y minus 4 by 5 is equal to z plus 8 by 6. Understood this question, my children? The required line is passing through this point and the line is parallel to this line. Okay, my children? So to find the equation of a line, what should we need? Yes, a point on the line and the direction ratios of a line which is parallel to the given line. Okay, my children. So this line is parallel to the required line. So let us find the direction ratios of this line. So direction ratios of line L1, that is equal to x plus 3 by 3 is equal to y minus 4 by 5 is equal to z plus 8 by 6 is equal to order triplet a comma b comma c, that is equal to the denominators, the numbers in the denominators denote the direction ratios of the line. If the equation of a line is given in the Cartesian form like this, then the three numbers given in the denominators denote the direction ratios of the line. Okay, my children, understood this point? So direction ratios of this line are order triplet 3 comma 5 comma 6. Okay, my children, right? Therefore the direction ratios of a vector or direction ratios of a line parallel to the required line are these only a b c 3 comma 5 comma 6. So we got the direction ratios of a vector or direction ratios of a line which is having the direction ratios a comma b comma c 3 comma 5 comma 6. Okay, my children. So the required line is passing through the point x1 comma y1 comma z1, that is a minus 2 comma 4 comma minus 5 and parallel to the line whose direction ratios are a b c, that is equal to 3 comma 5 comma 6. So we got the point x1 y1 z1 and the direction ratios of the required line. Okay, my children. Therefore the Cartesian form, therefore the Cartesian form of the required line x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. Okay, my children, this is the Cartesian form of a line which is passing through the point x1 y1 z1 and whose direction ratios are a b c. Okay, my children, remember this formula. In this formula, Simply we have to substitute x1, y1, z1 and a, b, c. Then automatically you get the required Cartesian form of the line. So x plus 2, I wrote directly x minus of minus 2, we get plus 2 by a 3 is equal to y minus y1, that is 4, by b 5 is equal to z minus z1. So z minus of z, minus of minus 5 plus 5 by 6. This is nothing but the Cartesian equation of the required line. Understood, my dear children? Right. Now come to the question number 7. Seventh question in the exercise. The Cartesian equation of a line is x minus 5 by 3 is equal to y plus 4 by 7 is equal to z minus 6 by 2. Okay, my dear children, this is the Cartesian equation of the line. Then we have to write the vector form. Okay, my dear children, in this exercise, this is very important to write a equation of a line in the Cartesian form and vector form. Vice versa. We have to learn this point well. Okay, my dear children. So in this question, the Cartesian equation of a line is given. We have to write the vector form of the line. Okay, my dear children. Right. Come to the solution part. Given Cartesian equation of a line is x minus 5 by 3 is equal to y plus 4 by 7 is equal to z minus 6 by 2. Okay, my dear children. Now let us write this equation in the standard form. In the standard form means in the numerator after x, similarly after y, and after z, minus sign should be there. Here x after minus sign is there, so it is okay. X minus 5 by 3, we write it as it is equal to, here first term is y should be, after that minus sign, but here 4 is plus 4. So we can write it minus of minus 4. Can we write it or not? Right. By 7, that is equal to, here in the numerator z after minus sign is there, so we write it as it is z minus 6 by 2. Okay, my children, so here we wrote this equation in the standard form, which is in the form of x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c. So the coordinates of the point a is x1, y1, z1, that is 5, minus 4, 6. Okay, my children. Therefore, the line is passing through the point a ordered triplet x1, y1, z1 is equal to 5, minus 4, 6. Understood this point, my children? And having the direction ratios of the vector. What are the direction ratios? The denominators. Previously I told you. The Cartesian form of a line is given. In that equation, the three numbers in the denominator denote the direction ratios of the line. So 2, 3, 7, 2. 3, 7, 2. This is the direction ratios of a vector. I wrote this vector in the component form. 3i cap plus 7j cap plus 2k cap. Understood this step, my dear children? So we got point x1, y1, z1 and b bar. So point means the position vector of the point A. Let us write. Therefore, position vector of the point A, that is equal to OA bar, that is equal to A bar. That is nothing but 5i cap minus 4j cap, 5i cap minus 4j cap plus 6k cap. This is the position vector of the point A. So OA bar, that is A bar. Here vector is B bar. B bar it is given directly here. 3i cap plus 7j cap plus 2k cap. So we got A bar and B bar. Therefore the vector form of the line, therefore vector form of the line is R bar is equal to A bar plus lambda B bar, where lambda belongs to real numbers. Okay, my children, understood this formula? Do you remember this formula? Right. This implies R bar is equal to What is A bar? 5I cap minus 4J cap plus 6K cap plus lambda into B bar 3I cap plus 7J cap plus 2K cap. That's all. We have to substitute A bar and B bar in this equation. Then we get the vector form of the line. Understood, my children? Right. Now come to the question number 8. Next question in the exercise. Question number 8. Eighth question. Find the vector and Cartesian equations of the line that passes through the origin and order triplet 5, minus 2, 3. Understood this question, my children? Here a line is passing through origin and this point. Then we have to write the vector and Cartesian equations of the line. Okay, my children? Right. Now let us consider the position vector of this point is A bar and this is the position vector of the point B bar. Okay, my children, let the given points, first let us write the given points. Origin 0, 0, 0. A point B, second point 5, minus 2, 3. Therefore, position vector of the point O. Therefore, position vector of O, position vector of the point O. Let us consider this is A bar. A bar is equal to 0 I cap plus 0 J cap plus 0 K cap. Point is given x1, y1, z1. So we wrote the position vector of the point O. That is considered as A bar is equal to 0 I cap plus 0 J cap plus 0 K cap. Understood this statement, children? Right. Similarly, position vector of the point A. Let us consider OA bar that is equal to B bar. Let us assume for our convenience, we assume that the position vector of the point A is B bar. That is 5I cap minus 2J cap plus 3K cap. These are the position vectors of these 2 points A bar and B bar. Okay, my children. We know that the line is passing through 2 points with the position vectors A bar and B bar. Is R bar is equal to A bar plus lambda into B bar minus A bar. Yes or no, my children? So we know that the vector equation of a line, which is passing through the points A and B, whose position vectors are A bar and B bar respectively, is R bar is equal to A bar plus lambda into B bar minus A bar, where lambda belongs to R. This is the formula. Okay, my children, if a line is passing through 2 points with the position vectors A bar and B bar, then this is the equation of the line in the vector form. Okay, my children, this implies R bar is equal to, what is A bar? 0 I cap plus 0 J cap plus 0 k cap plus lambda into, what do you get, b bar minus a bar 5 I cap minus 2 j cap plus 3 k cap. Yes or no, my children? Here I am writing directly b bar minus a bar value minus 2 j cap plus 3 k cap comma lambda belongs to R. This is the vector equation of the line. Okay, my children. Now let us write this equation of the line in the Cartesian form. Okay, my children. This is nothing but x1, y1, z1, and these are the values a, b, and c. Okay, my children. So we know that the Cartesian equation of a line, the Cartesian equation of a line passing through the points, we can reuse this also. A is equal to x1 comma y1 comma z1, that is nothing but here 0 comma 0, and b y2 x2 comma y2 comma z2, that is equal to, second point is 5 comma minus 2 comma 3 is x minus x1 by x2 minus x1, that is equal to y minus y1 by y2 minus y1, that is equal to z minus z1 by z2 minus z1. We can use this formula also, or just by using from this Cartesian form we can write the, by using this vector form of this line we can write directly in the Cartesian form. Okay, my children, right. This implies x minus x1, what is x1 by x2 minus x1, what will you get, 5 is equal to y minus y1 y minus 0 by y2 minus y1 minus 2, that is equal to z minus z1 by z2 minus z1 3. Okay, my children, understood this step? So x by 5 is equal to y by minus 2 is equal to z by 3. This is the Cartesian form of the line. Understood, my children? Right. Here I am not explaining the question number 9. That is the next question. Because the question number 9 is the same as that of this question number 8. Okay, my children, please try yourself question number 9. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children? Right.